Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So here is example 25. Determine the magnitude of the smallest resultant force and the direction theta of the 300 Newton force. So for the solution, so the analysis here is there are three forces. If we consider 400 and 300 only, definitely the resultant will be in that direction also. For the magnitude of the resultant to be smallest, it should be coincident with this 250 Newton force. So if it is not coincident with 250, then it will not be the minimum or smallest resultant. So there is already 250 Newton here. The resultant should be in that same direction so that we expect that its magnitude would be minimum as or smallest as possible. So that's the analysis. So this is the free body diagram, and we have here the resultant directed also along the 250 Newton force, and it makes an angle of 10 degrees counterclockwise from the positive x-axis. So Rx is equal to the x components of 400 to 50, and it is equated to the x component of the resultant, which is R cosine of 10. 300 Newton has no x component. Then Ry is equal to the vertical component of 400 plus vertical component of 250, then minus 300, and equated to the vertical component of the resultant, which is R sine of 10. So that's it. So Rx is equal to 400 cosine of quantity theta plus 10 degrees, then plus 250 cosine of 10. So only those forces have x component, both positive, then equated to the x component of R, which is R cosine of 10 degrees. Then Ry equals 400 sine of quantity theta plus 10 degrees plus 250 sine of 10, then minus 300, then equals vertical component of the resultant R sine of 10 degrees. So simplifying this Ry here, 400 sine of quantity theta plus 10 degrees minus 256.6 equals R sine 10 degrees. Then we divide this Rx here, 400 cosine of quantity theta plus 10 plus 250 cosine of 10 in the left side, then in the right side equals R cosine of 10, also divided. So simplifying, we can cancel R. So we can cancel R, and using your calculator, for if we cancel theta, 47.62 degrees. Then for the magnitude of the resultant, we substitute it into this equation here. 400 sine of quantity 47.62 degrees plus 10 degrees minus 256.6 equals R sine of 10 degrees. So from there, we can solve for R. R is equal to 467.6 newtons. Now for your part, here is your problem. This time P is unknown, theta is also unknown, and the problem is the magnitude of the minimum resultant force shown above is 500 newtons. Determine the magnitude of P and theta. So that's your problem, and show that P is equal to 422.6 newtons and theta is equal to 44.36 degrees.